amps. Let's say you're drawing 40 amps. It will switch to a hybrid mode, meaning that it'll give you the 20 amps that it's passing through the Multiplus, and it'll draw power out of the batteries to make up the difference so that you can be running on the 40 amps that you're trying to draw. You can do that up to 50 amps. Now, when your power usage goes down, it stops using that hybrid mode and it starts putting power back into the batteries. It starts charging your batteries again. So it gives you an amazing amount of flexibility. But because it has so many functions, we need something that can handle the split phase, the single phase, the inverter, the pass-through, and the hybrid mode. So that's why we have the smart phase selector that we're going to use in this video. It's basically a transfer switch. So I refer to it as the smart phase selector, the SPS, and a transfer switch, because it's basically a switch that transfers how that power is going to be delivered, and it does a fantastic job of that. So let's get back to it. So I hope that there's a couple of ways that this video can help you out. So number one, if you don't like messing with electrical, I hope that this helps inform you of the systems that are out there, that you can take these diagrams that I'm going to put on the website. You can go and print them, take them to an installer. You'll be armed with some information about the things that you'll need to get in order to make a system like this happen. So you should have a ballpark for price of what something like this would cost you. Number two, if you want to install this yourself, the diagrams and the walkthrough that I give you of how to install this should give you the ability to be able to do it. I actually just walked a friend through it, sent him the diagram. He was several hundred miles away and he just got his up and going yesterday. So I hope that all these tools and resources can help inform you whether you want to try and install or take it to an installer and have a system like this function on your RV. So let's start looking at some of the equipment to make this system work, and we're going to look at the inverter first. So we're going to use the Victron 3000 watt inverter. It's the 12 volt unit. So there's a lot of different options out there. The Victron is my favorite. GoPower has one. The problem that they have with that is it does power assist, but it only senses on one line. So people have often had problems popping the circuit that they're connected to because it's not sensing on both circuits. Xantrex has theirs out there. Magnum also has theirs out there, which is actually a really nice one. It's brand new, just hit the market. It's really pricey. It's on the very high end of being able to have a power assist inverter. I haven't been able to get my hands on it, so looking at the specs, it looks like it does just about everything that we're going to be creating here today in our setup, but it is going to be at the top of the price list. And the one that we're using today, like I said, is the Victron. I love it because it is extremely high quality. I think their quality is great. I love the things that they're coming out with, the development of their products. I think they're at the leading edge of the things that they're coming out with. So I think they do a fantastic job giving you a lot of control over the system, where you can change up the type of battery that you're using and exactly the charge parameters you want. A lot of customizable settings for in here, and the ability to change that with a computer, the ability to do power assist from your phone with Bluetooth. They really have a lot of great advantages, and it's why you see a lot of RVers going with it and why it's number one on my list. It's my favorite. I'm going to put links down in the description to everything that we talk about today, those inverters we just mentioned, and everything, the transfer switches, the tools, everything that goes into installing this and being able to make this happen will be down in the description. So you can check that out. But let's take a look at the system. So let me give you a brief overview of what we have going on here. Our two main components, this is our inverter, and then this is our transfer switch. This is the smart phase selector. So this is connected to the batteries. Number one, we have the positive lead coming over here to the switch. And on the switch, we also have connected a fuse to protect all the wires, and then that goes directly to the battery. On the negative side, we come down to a shunt. This is just so we can monitor how much power we have going in and out of the batteries. And on the other side of the shunt, it's directly connected to the batteries. The only thing connected negatively to the batteries is through this shunt. So this is how it's going to be able to have this charge the batteries and also power sent from the batteries to here when we're inverting. Now on the AC side, this is our shore power coming in. So this would typically be connected to the breaker box in the RV to be able to distribute to everything. But for us, we're gonna bring it to this system, which at first enters our transfer switch. So the line comes into here on this side of the transfer switch, and part of it, because it's 50 amp, is actually gonna bypass over here to come to the inverter. This is the input of the inverter, and then from here, whether it has a pass-through and allowing the power to pass through, or if it's inverting, the power will come through here back into our transfer switch. It comes into the top here, and then this will decide whether we have a split phase or a single phase power coming in, and then it'll distribute the power here, which will then go to our main breaker box in the RV. So you can see that there's a lot going on in there, but if you break it down into the different components, it's really not that difficult. And I'm going to show you how to route the wires and how to connect each one and what they go to with a detailed description. You couple that with the diagram you can get off the website, then it should really help clarify and simplify and make it understandable so you could follow right along. So we're going to have two diagrams, one with a manual switch and one with the SPS. This thing is actually amazing. It takes a lot of the human error out of it. You can achieve a lot of the same results, but you have to manually switch these things, and if you forget to switch it back over to 50 amp, when you do have 50 amp, then you may not be getting all the power you potentially could be. So this manual transfer switch will work, but this SPS is really amazing. But I'm gonna have diagrams to both of them on the website. Before I forget, with this manual switch is there's a detail on that diagram for how to wire this, because there's some jumpers and how it needs to distribute the power so that everything functions properly and safely. I use this isn't necessarily the only way to do it. You could do it with a single pole double throw switch, but those are harder to come by, harder to find for the proper sizing and amperage. And this is really easy to find on Amazon. So, but everything else we're going to do, because when I tried to wire that in, it worked and it functions great, but it was very messy because I didn't have a box to put it in. So everything's gonna be through this SPS. Now the reason why the SPS is so amazing is because it takes the human error out of it. It senses the power coming in and it knows whether you're plugged into a true 50 amp with split phase coming in and it distributes it properly, or it knows if you're connected to a 30 amp pedestal and that dog bone sends it to both legs. It needs to know that you are actually on single phase and it needs to distribute the power properly in that circumstance. So for instance, if we were to look at a properly wired 50 amp pedestal, we would see that between line 1 and neutral, we have 120 volts. Between line 2 and neutral, we have 120 volts. And between line 1 and line 2, we have 240 volts. We get 240 volts because it's a split phase system. Now, if we were to look at a 30 amp outlet that's wired properly, between line 1 and neutral, we'll see that we get 120 volts. But if we look at the back of the adapter for a 30 to 50 amp adapter, we see that there's a little jumper that goes in between to be able to send that power to both line 1 and line 2. And this will actually protect you if they've bootlegged the 50 amp pedestal over there and they're sending you single phase when you think you're getting split phase. This detects it and handles it properly so that you can use your RV without overloading the neutral wire. But that's a different story. So inside the main panel in the RV for real world use, I don't have a 50 amp panel with me, so I'm just going to use this plug so we can see exactly what's happening and how we're getting the power at the different circumstances. So when we flip on the breaker for the 50 amp inside the panel, we'll have line 1, 120 volt, line 2, 120 volt, and between line 1 and line 2, we have 240 volts. It's properly wired. Now, if we were to be on 20 amp, we will see the voltages differently. On line 1, we have 120. On line 2, we have 120. And between line 1 and line 2, we have 0 volts. That shows that we're on single phase. So that's what we get when the system is working properly. But it's important to know, just because we have power available everywhere when we're on inverter or power assist mode, it doesn't mean that we can just turn on everything just like normal. You need to know how much you're able to plug into, how much you can have in power assist, and don't go over that. Just because we have power available everywhere doesn't mean you can just turn everything on. You do still need to watch your power usage. So that's how the system functions. Let's look at the inside and how to connect everything. So on the inverter, we can slide off the cover and it's where we're going to make all of our connections inside of there. These are the wires from our main shore power coming in. On the SPS wiring diagram, you can see that they just literally show where you can cut the wires that go into your main breaker box. That way you don't have to yank the wires out of your breaker box. You can cut it where the SPS is going to go, where this switch is going to go. As long as you would have enough slack in the line to put both ends into this SPS. This is our shunt for the battery monitor. One end is going to go to the inverter, which everything else is going to connect to on that side of the shunt also in the future. And then the other side of the shunt goes directly to the batteries. On the positive lead, we still have this large 4-aught wire. It connects to the inverter, which then goes to the disconnect switch and the fuse to protect the wire, which then gets connected to the battery. Now we can start wiring up the smart phase selector. They even have a wiring diagram on the front, but our main shore power line coming in is going to the upper right corner of this switch. Now our green wire is going to go into the ground bus bar. Our white neutral wire is going to go into that center terminal. We can wait to tighten that down, and line 2, the red wire, is going to go into that far left terminal, that first terminal. Then our black wire we're going to set aside because it actually gets spliced in to go directly to the inverter. Now we can wire up our cable that goes into the inverter. So our black wire goes in that first position for line 1, our neutral in that center position on the end of the inverter, and our green for the ground goes in that far right terminal. The other end of that cable is going to go back to the smart phase selector. So the upper left corner of that box, it's going to go into there. Again, our green wire is going to go to the ground bus bar. Our white neutral wire is going to go to that center terminal on the far right side, along with the other white neutral that we had coming in from the shoreline. And our line 1 black wire is going to get spliced with the original one that we brought in. You can see that these black wires getting spliced together, it's bypassing the switch to go straight to the inverter. It comes with the hardware to make the splice on this connection and the heat shrink tube. So you want to heat up that tube. It has some adhesive in there, so you want to heat it up so it gives a nice and protected, a nice tight seal around it. Once that's done, we can tuck it into the bottom and just move it out of the way. Now we can wire the out of the inverter. Our hot leg, the black wire, will go into that first terminal of the out. Our neutral will be in that second terminal, that center terminal there, and then our ground wire will be in the right terminal of the out. That wire comes across back into the smart phase selector on the bottom left of that box. Again, our ground wire is going to go to the ground bus bar, and our white and black wire are going to go into the upper left section of this switch. Just a tip, making these connections with this thin stranded wire, you can use a ferrule or these sleeves to be able to make these connections a lot better so you don't have these thin wires going everywhere. It would keep it nice and tight and give you a nice positive connection. While the front of the inverter is open, we can wire in the Bluetooth for the inverter. It has a Cat5 cable that connects into its port, and then you can use the positive and the negative leads in here to power it so it's on when the inverter's on. Now, the last connection we have to make in here are our main wires that go out to the main panel. So our black wire is going to be in that right terminal, our neutral wire will be in that center terminal, and our red wire will be in the far left terminal on the bottom of the switch. And then of course our green wire will go to the ground bus bar again. You want to tighten everything down, make sure those connections are really tight so that nothing comes out. As far as using this inverter for the hybrid and inverter, they make it really easy to use. They have apps where you can download it and you can see what's going into your inverter and what's coming out. You can change the limit depending on what you're plugged into. So it's really user-friendly and works really well. But talking about a 30 amp installation, it's a lot more simple. 30 amp is really easy because it's always only going to be single phase. We don't have to worry about the split phase. So we're not gonna have a transfer switch because that's built into our MultiPlus. It has a 50 amp transfer switch inside. So if we begin the install, we see that our power comes to the MultiPlus, which is connected to our batteries through the shunt on the negative side, and on the positive side we have our shutoff and our fuse. The line out for the AC line goes to our RV breaker box. On this setup, we have the benefit of it being an inverter, having the power assist, and it acts as a UPS, an uninterrupted power supply. So the microwave clock won't even turn off because the MultiPlus actually syncs itself with the power that's coming in from the grid and then just picks up where it lifts off. The transfer switch is so fast inside that the computers or anything like that, the processors won't actually shut down. Close enough to instantly to where it doesn't shut the power off. So I hope this video helps you understand how to install an inverter on your RV with power assist function. There's other ways to install an inverter in the RV without the power assist, and there's lots of different ways that you can accomplish that, but they come with their own problems and drawbacks. So I hope this helps you out. So if you like this video, give it a thumbs up. If you want to see more videos about RVing, hit that subscribe button, and if we don't see you on the road, hopefully we will see you next video. I'm Jared Gillis. Welcome to another All About RVs. Today we're going to be looking at a new inverter system, and their slogan is simple, smart, and compact. And we're going to try and put it through its paces because it's actually pretty powerful. So this here is the EcoFlow Power Kit. It's an entire ecosystem of how to set up an inverter and solar for an RV. So some people might be intimidated by a system like this. When I look at it, I see quality, customization, versatility, but some people might just see intimidation. They don't really know where to start. So with this Power Hub, they're trying to make things much more simple. So everything is going to connect to that Power Hub, and a lot of the components that we have on this system are basically tied together internally in that Power Hub. So solar charge controllers connecting to your alternator, being able to have the AC and DC in and out, all of that is going to connect directly to the Power Hub and have some smart controls. And that Power Hub, the inverter inside has a 3600 watt output. So that's pretty much anything that you'd want to power in a 30 amp RV. So at first look, this is a compact system, and it's different than the other things that they've put out previously. Usually those are portable power stations, and this is something that you can install on your RV. But I want to rewind a little bit and take you along with the install process, because with it being simple, it should be easier to install. But I want to walk through that rather than just a display of it. I want to actually install it on an RV and show you what the process is like. These batteries are kind of interesting. They're a 48 volt battery, which is different than you typically see in an RV. This is a 2 kilowatt battery, so I have two of those for 4 kilowatt hour batteries, and they have a 5 kilowatt battery, so you could do 3 of those on there. So you can make a pretty big bank, but you can also use these batteries in other areas. The neat thing about them is they have a DC fuse on them, and they have an internal heater for those low temperatures. It's heavy. Why am I holding it like this? So the two batteries combined is going to be around 4,000 watt hours, which is about 3.5 100 amp hour batteries to kind of give you a ballpark. So for our test, we're just going to do 400 watts of solar. The unit itself can take 4,800 watts of solar, that's an insane amount of solar. We don't even have that much roof space, but 400 watts will give us a good test. Okay, I ran into a little bit of a snag trying to install the RV, and so I'm gonna have to come up with a little bit different game plan. What happened was I opened up the smart distribution panel and I realized that every single breaker in here is a 20 amp breaker, and I can't swap them out. The way I was going to set it up, I needed 20 and 15 amp breakers inside of here to run it as a sub panel. Because the way that I see it, this inverter can be installed two different ways. If you have a 30 amp RV, this has the capabilities of being able to have 30 amps in and 30 amps out. So that would work fantastic. And if you're doing something like a van build where you're just going to be starting from scratch and building your own, you can work off of 20 amp circuits and just build everything that would work on a 20 amp circuit. But with our 50 amp RV, we already have a lot of the wires run through the RV, so we needed to be able to accommodate that. So I was going to do it as a sub panel. So that meant our main breaker panel, I was going to put in a new 30 amp breaker that would then feed this sub panel, the smart distribution panel. And then I would take things out of there and have them run through this. So the AC or outlets or different circuits that I wanted to run on here. So if I'm doing the AC, that would be completely fine because the AC is a 20
20 amp circuit, so that would come into the smart distribution panel just fine. But if I'm moving over the outlets that's on a 15 amp circuit that has 14 gauge wire, it would then not be protected by the 15 amp breaker that would be required to protect it. So with a 20 amp, you run the risk and the possibility of having it overheat, melting the wire, causing a fire. Those are the things that I didn't want to do. So I'm not going to set this up as a sub panel, and instead I'm just going to power the entire RV off of this. So everything still has the protection of the existing panel in the RV, and we'll see how well this does, because this is still a beast of an inverter. But with all that said, I'm still going to put in a false wall here and put in the smart distribution panel and install some of that so you can see how that would all lay out and work together. So now that we have everything mounted, this is where the simplicity part comes in, because everything just becomes plug and play. So you don't even need a wrench to connect the batteries to the power hub. You just have this connector, you plug it into the battery and you plug it into the power hub. So same with the distribution panel and the solar, you just plug it into the hub. So with all that connected, we can now see that the solar is charging. If we connect it into AC power, we can charge that way too. We actually have a setting in there where we can limit how much it's going to charge. So if you're plugged into 30 amp, you can crank that all the way up to receive the maximum amount of charge from AC that you'd want it to. Or if you were only able to plug into like a 20 amp outlet, you can bring that down to 20 amp so that you don't pop that breaker. But I think it's time to plug the RV into the system and see what we can run. So let's start off turning on something big. So we have things like the fridge and some other stuff on. So we're pulling about 750 watts right now, which is quite a bit. But let's go ahead and crank down this AC. Takes a minute because the micro air easy start. But there we go. AC is up and going, no problem. Let's turn on something else. Okay, so here we are right now running just under around 2,000 watts. And if we turn on this tea kettle, another large item, that's going to bring us up to 3,220 watts. That's a lot of watts, and it's sustaining it. Both are running. The AC's going just fine. The tea kettle's going fine. It's nice to know that it can run a couple of large items like this when you need to. Okay, I wanted to sit down and give you a few of my thoughts about the system, because everything that you saw up to this point was the install day and that initial test. And we've had it for about a week and a half. So I just wanted to step back and look at the system as a whole. And this is a really interesting all-in-one unit, because there's other all-in-one units out there, but this one is specifically designed to be able to go into an RV. You can use it on a cabin or something like that, but the way that it has the 12-volt DC output, or 24-volt if you wanted to, it has that option in there. It's really designed for a van life kind of an install. And the install really was pretty easy. The way that they have everything labeled, the packages, so you know that this cable is meant for the battery to the hub. You knew what all the different cables were for. The only cable that I needed to provide was the one to be able to have the unit grounded. So it has a terminal screw on the side, and you connect that to the frame of the RV. And I had a timer going. I wanted to see how long it took to install this. So once I had mounted the solar panels and all the hardware and connected all the wires, that was about 4.5 hours. Now, the one caveat I had there is I didn't run all the wires the way that I wanted to for the finished product. So I had to come back and run wires from the ceiling down to the power hub for the solar. And I did buy a wire for that too, because the one that came with the power hub, it had the MC4 connectors on there. I didn't really feel like cutting those off, but chasing the wires through the tight areas of the wall, it was just easier to do it that way. So once I tally all that up, it was about just under 7 hours to get it all installed. Overall, I've been pretty impressed with the power kit. We've mainly been charging it by solar, and the output of the inverter is quite impressive. We've had to do a couple of firmware updates. I had some questions of some functions that weren't quite working, but they came out with firmware updates, and all of that is functioning now. So it's been fun to use, and it's pretty easy to set up. I would think that the hardest part, if you're not used to upgrading RV electrical equipment, the hardest part might be bringing in the AC power, trying to figure out how you're going to bring that to this unit, and then the AC power out, how you're going to get it to all your different circuits in the RV. If you have a 30 amp RV, that's a lot easier. But I think that's going to do it for today. That's my initial thoughts on this unit. I do have to say that they did send it to me for review, but I am genuinely impressed with it. But it'd be fun to compare this to some other systems that are out there, so we might do that in the future. So like I said, I think that's going to do it for today. So if you guys like this video, give it a thumbs up. If you want to see more videos about RVing, hit that subscribe button. And if we don't see you on the road, hopefully we will. See you next video.